This is my Heathkit model ET-3400 microprocessor trainer. It's also called the Microcomputer learning system. This is one of the more obscure pieces of Heathkit equipment that I own. This piece of equipment came out around 1977 when Heathkit was already under the Zenith company, as you can see here. This is, by all definition, a computer to the lowest common denominator. And by computer, I don't mean CPU. I mean, as we would define a computer today, it has an input, it has display, it has I/O, it has the ability to output. It is a computer. It even has software. Believe it or not, on this ROM sits the monitor software to be able to enter the programs. It has editing capability and what have you. I mean, really bare bones. And the premise of this was simple. This is to teach you how to program and how a 6800 Motorola microprocessor works. It wasn't anything else. That's all this thing was for. Commodore MOS Technologies back in the day had the KIM, which was very similar to this, that also performed the same task for the 6502 processor as well. The keyboard is a hexadecimal keyboard that also has commands that's built into the monitor for extra functionality. It also includes a reset key. The key buffer is shown here on top of the D, E, and F keys. The output of the device includes 6 7-segment displays as shown here. It also has next to it the letters that are used for the registers of the processor, H, I, N, Z, V, and C. Just below that we could see the ROM and its location in memory, hexadecimal address FC00. And that ROM is the software monitor that's used for the loading and editing of basically memory addresses, which is the loading and editing of software in this unit and the executing of that software. The RAM is right here. These are 128 byte ICs for a total of 256 bytes. I know that the monitor ROM takes up a significant amount of that memory address space, including hardware mapping to it. So you're only left with about 128 bytes for usable memory area for writing software. Not that you could do much with this thing, so that seems to be an acceptable amount. The other relevant piece of hardware on here is obviously the CPU. This is a Motorola 6808 processor. We could see a crystal here, 4 megahertz crystal off to the top right. This processor operates at 1 megahertz. Interesting note, if you work on Commodores and Apples, is there's an A accumulator and a B accumulator on this processor, something you won't find on the 6502. As far as the register, there is an X register but not a Y, so a little bit of a trade-off. Just interesting to note that. There was a whole other system, an I/O add-on and things of that nature that would allow for cassette backup and teletype terminal and serial port interface to be loaded on a box that was pretty much twice the size of this unit itself in order to accomplish that task. And it went into this jack down here, which isn't even installed. It was part of an upgrade package. By the time you were done with this, you ended up with a computer for which you've already paid enough money to have pretty much a complete computer anyway, which you could have foregone this purchase. So when you consider at the time, you still would have needed a terminal and a teletype and a tape recorder and what have you in order to do that. At that point already, I guess at 1977 it was slim pickings, but by 1981 already, you know, you would have had some more options, such as like a VIC-20 or an Apple II. It would have been a much better choice to learn how to program on a processor and assembly than something like this. With that said, in answer to the question, should somebody buy something like this to learn how to code on an old style 8-bit microprocessor? My answer is absolutely not. Never do this. This computer didn't even come with a character map, right? So in order to do this demonstration, I had to write my own fonts so it would print out letters on the LCD. I mean, that's what we're working with here. So if that gives you any idea of what's going on or foreshadows it, then yeah. So we'll do just a brief demo of functionality. We're not going to go too deep into this, but I'm going to turn it on. And I have the feeling that this thing is always on, and the on button just makes the lights turn up and basically hit reset. And what you can do from here, well, you could do a lot of things, right? So you can see where the current program counter is. and you can see that it's on memory address 0012. So if you were to let this thing execute, that's where it would start executing from. You have break. I could set the program counter to a particular location. I could single step it, and I could do FC00. And yeah, okay, so FC00 is the ROM, just there it is. So the thing is running, hit program counter, and I guess 00G9 is where the current instruction is. So I just hit reset again. I could look at the accumulator. The value in accumulator A is 46. The value in accumulator B happens to be 46. There's the processor flags. The most important thing in this monitor is the ability to add stuff into memory, view stuff in memory, and execute stuff in memory. So if I want to examine a location, memory 0023, I just hit examine 0023, and there it is. I could hit forward to see the next one, the next one, next one, next one, next one, and we can see the numbers are incrementing as I do it. I can hit back to work my way back. If I want to add stuff into memory, I can hit the reset button and I can hit auto. Auto is a nice feature if you have to type in programs, because I could start at an address 0030 and I could start adding in numbers 01, 02, 03. Each time it's incrementing 04, 05, 06, 07, 08, 09. If I now wanted to review that, I could hit reset. I could examine 0030, and we can now see that what I put into memory, into these RAM chips, we can see it incrementing exactly as I typed it in. 6, 7, 8, 9. Now what comes next, who knows, because I didn't type it in. Now just random data. So I hit reset again. Once something is typed in and it's reviewed, I can hit the do button. And if I type in a memory address, the processor will start executing that code, for better or worse. So it could crash and destroy everything, and everything will be lost, or it'll execute and will leave gracefully. Nobody knows until it happens. That is the cliff notes of how this thing operates, and that's all it does. At work last week, I put my foot in my mouth, and I said that a particular thing would run on this unit in 128 bytes, and for that I do have to make a program for this. So this is a sort of a spin-off of some existing code, and this merges with some code that's already in the monitor. One of the tricks to writing stuff and fitting it into memory is the fact that if monitor routines that are already in ROM exist to do some of the functions, you can offload that by making calls to those functions. You could see here routines where you're jumping to FCBC is in monitor territory, and stuff like that allows you to write code that calls existing code without having to write it. Thus, you have a smaller code base. Also had to make the custom fonts that allowed for this code to happen. This is the most painful part of the process, so let's get started. And that about finishes it. Now it's time to review it. Okay, I believe I fixed all of the errors that I made while typing in the software. Now the correction that should be it. Having loaded the software into memory, starting at memory address 0, I can now hit the do button and load memory address 0 for execution. So this is DAS and UCF running on the 3400 Heathkit microcomputer. I guess we could say this is the oldest implementation of DAS and UCF running on any computer now. So here we go. I put my foot in my mouth, but I made up for it. Thanks for watching.